In this lesson, you will learn about proportions in a triangle. Certain segments will divide sides of a triangle proportionally. So let's look at their objective is to use the side splitter theorem, and we're going to also have a corollary to that, and the triangle angle bisector theorem. So the first one, the side splitter theorem, it says if a line is parallel to one side of a triangle and intersects the two other sides, then it's going to divide those sides proportionally. So let's look at this diagram. We have line RS is parallel to line XY. So RS is parallel to XY. So if that's true, then we can say that segment XR over segment RQ is going to be equal to segment YS over segment SQ. If we had, let's say we had values for the lengths of this, of A, B, C, and D, then we would have A over B equal to C over D. There's a corollary to this theorem, to the side splitter theorem, that says if I have three parallel lines intersect two transversals, then the segments intercepted on those transversals have to be proportional. Remember, a transversal is just a line that intersects two other lines in two distinct points. So here we have three parallel lines. So if line A is parallel to line B, is parallel to line C, then we can say that segment AB over segment BC is going to be equal to segment WX over segment XY. Last theorem is the triangle angle bisector theorem. So let's look at that one. This theorem says that if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So here we have ray AD that bisects angle CAB. So if ray AD bisects angle CAB, and we know it bisects it because they have congruence markings drawn there, then segment CD over DB equals, since I named it CD first on the left side, I have to go back and name the leg of the triangle, or the side of the triangle that's adjacent to CD, which is CA. I have to put that in the numerator over on the right. And then on the denominator, the side that's adjacent to DB, which is BA, has to be put into the denominator on the right side. So let's look at some examples that use these theorems. In problem 1, it's asking what the value of x is in the diagram. So we can see that this is using the side splitter theorem because it has the parallel markings. So it says that if a line's parallel to one side of a triangle, then it intersects the other two sides, then it's going to divide them proportionally. So if we look at that theorem over on the left, to see how to set that up, you're going to take the segment that's represented by the 4x minus 2 and put that over the segment that is length 9, and then you're going over to the right side, the segment that's 3x plus 2, and put it over the segment that's length 12. So once you get your proportions set up, you cross multiply. Don't forget to use the distributive property. When you multiply 12 times the 4x minus 2 and the 9 times the 3x plus 2. So you're going to get 48x minus 24 is equal to 27x plus 18. Subtract the 27x from both sides, you'll get 21x on the left. Add the 24 to both sides, and you're going to get 42 on the right. Divide both sides by 21, and x is equal to 2. In problem 2, you have two plots of land that are shown, and it's asking again for the unknown length x. So this is the corollary to the side splitter theorem, where we have three lines that are parallel, that are cut by two transversals. So it divides those transversals proportionally. So to set this up, we can set up the 62 over the x on that side is equal to the 56 over the 70 on the other side. So cross multiply these, and you're going to get 56x is equal to 4,340. Divide both sides by 56, and x is 77.5 feet. Last problem is using the triangle angle bisector theorem. In this problem, you can see that you have a segment going from a vertex to the opposite side, and it bisects that angle because of the congruence markings. So we know that the triangle angle bisector theorem applies. So to set this up, you're going to put the 9 over the 15 on the left side of your proportion. So since I used the 9 in the numerator of the fraction on the left, I have to use the x because it's adjacent to the 9. Got to use the x in the numerator on the left side. And since the 15 is in the denominator on the left, I got to use the 25 in the denominator on the right, because those are the two sides that are adjacent to each other. So now you cross multiply. 15x is 225. Divide both sides by 15, and x is equal to 15.